Welcome everybody to another edition of Coffee and Open Source. So pleased to meet some new friends, have some great conversations, and maybe learn something along the way. I'm your host, Isaac Levin. And if you're enjoying the interviews here, be sure to like, subscribe, follow wherever you're watching or listening. Also, if you're interested or know any folks that would be interested in coming on chatting, feel free to reach out to me on Twitter. My handle there is IsaacR11, or reach out to me on Mastodon. My handle there is IsaacR11 at Fossadon.org. All right, so with that out of the way, let's get to our guest. We're having a great conversation before we got started, and I'm really looking forward to it. My guest today is Vlad Ionescu. Vlad, do you want to say hello, introduce yourself?
Yeah, hi everybody. My name is Vlad. I'm the founder of Earthly and also the founder of ShiftLeft. I'm also an ex-VMware engineer and ex-Google engineer, and I've also worked on some of the initial pieces of RabbitMQ back in the early days. So yeah, thanks for having me, Isaac.
Yeah, I'm really looking forward to the conversation. We were having some really interesting little moments before we got started, and I think you even said like, "Hey, I want to say this on stream. Like, let's not talk about this." So I'm looking forward to it. I really like to begin our conversations with origin stories. Like, I'm a superhero fan. And I love the idea of like how folks got started in tech, because everybody's stories there are some similarities, but everything's a bit different. Like, do you remember the first time you came across technology and you realized like this is the thing, like this is what I enjoy working with?
Yeah, for me it was more like a progression, to be honest. Like, it started when I was maybe 12, and we had this family computer, and like we installed a modem and a CD-ROM in it. And they didn't work. And then somehow I figured out how to make them work. Like I opened up the computer, switched up some ribbon cables, and then installed some drivers and such. And I made them work. And I was just 12. And my parents were like, I have no idea how to do this stuff. How does he know how to do this stuff, And I think many parents have gotten that, like our generation is more tech oriented.
Yeah.
And so,
yeah.
That was maybe my first interaction, with technology. I didn't know it was going to be a career for me back then.
Sure,
it was just something interesting and sort of geeky that I was doing.
Yeah.
And then maybe like there was the programming interaction. So I was maybe, when was this? Like I was in ninth grade. No, I was in 8th grade, and my sister was in 9th grade at school. And in some high school tracks in Romania, you would learn some programming if you chose to.
Okay.
And my sister got into that programming class. I mean, she's not very good at computers necessarily. Like she's average, not necessarily didn't build a career out of it, but she took really good notes. And somehow I read those notes and they seemed really interesting to me. And I learned C++ just from reading my sister's notebook.
Oh,
so
wow.
They were like, like there were if statements and while loops and for loops and so on. And I remember arrays were particularly challenging to me. Like I didn't really get them initially, and especially that they started at 0, right?
Yeah.
And so initially I just ignored the first element. I would just start from 1 onwards, and just made them work for me. But yeah, that was my sort of first interaction with this stuff.
No, don't feel bad. I remember like my first programming class and like trying to learn the concepts of pointers. And I was very much just like, I don't even know. Like, I give up. Like this, like there has to be some easier way. Like, why do I need to like care about this address in memory versus like, and I remember like I had a TA who just, I don't remember exactly how he described it, but everything kind of clicked. And I'm like, oh, okay. But like, still, if you were to ask me, 15, 20 years later, like, why are pointers important? I'd be like, oh no, I don't know. Like,
yeah, exactly.
Yeah, I mean,
Right.
So I think there's some similarities between you and I, because like, I think a lot of people have heard one of my origin stories. Like my parents, we got a computer, brought home. I took it apart like the second day we had it. Like,
oh, wow.
Opened up the side, like it was an old HP Pavilion computer. I took it apart and I like was playing around with everything, and like my dad walks into the room and he's like, fix this now. And like
How
I had to
old
like,
were you?
I was a teenager. I was like 12, maybe 12 or 13.
Yeah, similar age.
And before then, like I had done like there's computers at school, and like I was always very fascinated about playing games on like Mac, like we had Mac 2s in school, and I remember just wanting to play the games and stuff like that. But I remember like frantically like having to kind of figure out, okay, like this goes in here and then I have to connect this, but I can't do like, and it obviously turned back on, or else I wouldn't be here today. I'd be dead. But like, I love the idea. And here's a question for you specifically, like, has that sort of like curiosity and that like tinker mentality, like wanting to build things, has that kind of carried with you? Like obviously through a software perspective, yes, but like, you know, everything else, like I know a lot of us in tech are very interested in like, you know, Raspberry Pis and all that sort of stuff. Have you kind of like delved into like that tinkering stuff? Is that something that's interested to you, or you're like, no, I like moving bits around on the computer, like making sand kind of intelligent. Is that your thing?
Yeah. I think mostly on the software side has been my thing. I thought about some sort of physical hardware stuff, but it just didn't take off for me. Like I was doing sort of the basic physics of it, like the basic circuits and not so much electronics. And yeah, I would say I studied physics in high school, and I was in the national team at of Romania of physics, and that was a big sort of there was some electricity as part of it, but not so much hardware, not sort of electronics and all that. I think my tinkering has more so evolved towards the software side. And I was doing some things in high school that I didn't realize they were sort of special. I just thought people did those things. Like I built this little graphics engine in MS-DOS, and like no graphics card, no nothing. All the projections were like manual. Like I just did the math on paper, basically. I didn't know about matrices and all that, the stuff they use these days. I just did like vector maths essentially, and just rotated things and like transposed and such. I built this little graphics engine that I was showing to people at school, like just to my classmates. And that I got a really good high from it. I really liked showing people off, my stuff, what I did. And in a way, I realized later it was kind of like a product. I didn't realize it then, but like it was basically a demo I was giving them, my classmates, and I would get like reactions in return. So like that was the value exchange there, like I didn't realize it then, but like, it was an interesting sort of interaction.
Yeah, that's like your first ever conference talk, right? Like that's that's pretty that's pretty
small
funny.
Scale, like really
like you're like on like looking at all the thing. Yeah, no, I mean I can relate a lot to like as well, like you said something. The idea is like you just assume everybody gets it, and then you find out at some point in time like, oh, like I'm one of the only people that get it. Like maybe I'm a bit more fanatical about this. Maybe I like this more than the average person. I remember it wasn't until high school. Like I had a web design class in high school where I learned like HTML and CSS and JavaScript. And I remember like there were so many like people in that class that were just like going through the motions, like, okay, like this is here and this is here. And I was like actually interested in it, right? So like I was trying to figure out like how to do weird stuff with CSS and weird stuff with JavaScript. Like this is like early 2000s, late 90s. So like you can get an idea of like the horrors that were being built, right?
Oh yeah.
So, and it's funny because a lot of folks just look at what I was doing and are like, oh, you can do that? Like that's the thing, right? Like I think as technologists, I think we have this, we assume that like other people can just pick things up in like from a technology standpoint, like we can. And then it hits you like really hard in the face. Like, oh, I'm a bit different than the rest of like the other folks that are working on things, right? And I mean, I imagine you feel similar things. Like if some folks really care about math, some people really care about science, right? And then you have the rest of the people that are just trying to like get through it.
Yeah, exactly. I mean, it's the engineer's curiosity, which sort of sometimes we take for granted, but other people don't necessarily have it, don't have that kind of curiosity. And really for me, it was more like, I know these really, really basic constructs, but what are all the things I could build with these really simple primitives? And I would just explore that and like build something that people never thought about building. And I just liked impressing my classmates. It was sort of interesting, sort of dynamic.
Yeah. So I imagine then at some point you realized, okay, like I'm good at this. This is something that interests me. Like maybe this could be a career. Like at some point it does dawn on you like, okay, maybe there's a career here. Were you already in university at that time? Or is it before you were in university?
It was just at the beginning of university. So I thought physics was going to be a big thing for me. And I wanted to go to the physics university in Romania. And then the entrance for physics university was, the requirement was like, you have to have 5 at the baccalaureate, which is something really like it's 5 out of 10, which is like a really small sort of mark. Right. And many people told me like, don't go there. Like only failures go there. So like I thought, okay, I'm going to go into engineering, and like I really liked physics. So I was thinking like mechanical engineering sounds cool and so on. Yeah. And people were like, no, this other course is in high demand. You want to be there because that's where all the Olympic people go, and that's where all the smart people go. And I just went there accidentally. Basically, it was the computing course at the Polytechnica University of Bucharest, and I didn't realize it's going to be my whole career, but I just liked it. After that, I transferred over to Imperial College in London, but basically that decision that physics was not in high demand, that sort of changed the entire career for me somehow. And I just stuck with it because I liked it.
It's quite interesting. I mean, obviously physics is in very high demand. I mean, I think it is one of those things where it is kind of funny, like based on some advice, like we can go on these weird paths, right? And like I totally relate to the idea of like engineering sounds cool. Like I have a friend who's a mechanical engineer, and I follow on Instagram, and I'm like looking at the stuff that he works on. Like he works on like oil rigs. Like he gets flown in, like helicoptered into oil rigs to like fix stuff. And I'm just like, I'm like, you kind of like a little bit of like a superhero. Like you a little bit like,
right.
And like
exactly.
And like, the idea of like building bridges or building all these things, like the civil or mechanical engineering is very, very cool, right? Especially like if you're very into tinkering and like figuring out how things work, like all of the physics that goes into that, right? But it is funny to say, like,
exactly.
If, looking back, like in all of those time, like, do you wish that you might have pursued physics a little bit more? Like, obviously that advice worked out very well for you. But sometimes you look back and you're like, oh, like maybe I could have been a particle physicist working on, nuclear energy or something really interesting, right? Like, have you thought about that? Or is it something that you've kind of like paid attention to throughout your life after?
Yeah, I've always thought about that. And, it's hard. It's hard to think about what might have happened.
Yeah.
Over time, my mode of motivation has always been work on the stuff that is most impactful. And that has been sort of driving my whole sort of journey so far. And I feel like right now there's a big demand for software engineers, and it's it makes sense for me to work in this area to make people more productive in this specific area when there's so high demand.
Yeah,
I feel like in physics, particle physics sounds really cool, and there's some amazing technology like, I don't know, fusion reactors and stuff that people are building these days, right? And they might save humanity or whatever. These are really, really amazing things. It's just hard to imagine where exactly my career would have led.
It's quite interesting, and I think I'm similar to you, is that I tend to not like think like historically, like that's the past. It is what it is. Like I am happy with the choices that I've made. Could I have made changes? Yes, but like it doesn't matter. But I think one of the things that I've done is I'm a very curious person by nature. You are too, I can only assume. So I'm always paying attention to everything, right? Like, you see like some new things coming out of like some collider work that's being done in Europe or whatever. You're like, oh, that's interesting. Let me read an article. Or, the telescope they just put up in space, the James Webb Telescope. It's like, okay, let me see some really cool pictures of space that I'll never probably see if it wasn't for this technology, right? So I'm always like curious and interesting.
Oh yeah. And I might have liked rocket science. That seems really cool. Yeah. Like that stuff. It's
I have a friend who's an aerospace engineer. He works at Pratt Whitney. And he very much is like, there's some cool stuff, but like, it's not as cool as you would expect. Like he's talking about being in meetings all the time and like talking with business people who don't know the engineering, the technology. And I'm like, oh, so it sounds like software. Like
exactly.
I kind of figured out at some point, like all the really cool jobs, they only sound cool on the outside. And then at the end, like all of it is basically the same job.
You know, what's interesting about our field is that we have this very tight feedback loop. Right?
Yes.
Where we do something and we can see the reaction of people, we can make an impact, we can test very fast. In aerospace, like to test a rocket going to space, it takes months, right?
Well, yeah. And it's crazy to think about
slowly.
it. Yeah. Like I think, and I imagine you had professors in university that were like, back in my day, I had to go and take the punch cards and wait 2 days, like all that, right? Right. And like that just seems like absolutely barbaric, right? Like now it's like if our build takes longer than like 2 or 3 minutes, we get very antsy, right? Very impatient.
Exactly.
And I could not imagine. I'm a very impatient person by nature, and I think the idea of like the aerospace thing is super interesting to me, specifically because like SpaceX has kind of figured out like how to do these things very quickly, where else the entire industry for 60 years hasn't been able to do that. But they still take months to iterate. It just seems like they're always doing something because they're testing so many things in parallel. And that's what's very interesting about the whole thing.
Even there, like these newer sort of technologies, they still use software to iterate fast in a like demo environment, simulation and all that, and I guess it's not as good as production, right? We all know that.
No.
But it gets you some of the way there. And I guess that's sort of, I can see how you could apply sort of software engineering principles to classical sort of fields nowadays a bit more and make them a bit more sort of tighter feedback loop.
Yeah, and I'd love to talk to you a little bit about that particular, like the developer experience, right? Because I think, as somebody like you who's been a developer, you've worked on small things, you've worked on large things, like, is there a happy medium? Because this is my opinion. Like if you have a long feedback loop, like I mentioned, you kind of get a bit antsy or whatever. But if you have too tight of a feedback loop, if things happen too fast, there is a lot of pressure, right? Like from your experience, like what is the medium? Do you like, being able to like breathe a little bit during those iterations? Or does your brain need to always be on fire and like, okay, boom, boom, boom. Like you're just smashing keys all day long because there's literally like no break in anything.
Yeah, I think we're all humans, right? So we have to take breaks. I think I'm on the side of the faster, the better, the tighter, the better. Because like then you have the control yourself. Like it doesn't have to mean you're going to work, just 8 hours straight and just, typing on the keyboard without any sort of breaks. But I think generally tighter feedback loops allow you to be more productive and be more sort of responsive. Like there are new ways in which you end up working with software if those feedback loops are tighter. And it's interesting when you ask different parts of engineering, like different programming language sort of users, they will give you a wildly different sort of expectation of what a tight feedback loop is.
Sure.
Right. I've heard in mobile, like the build times are like 45 minutes. That's fast.
Yeah.
Whereas when you work with front end and CSS and JavaScript and all that, like instant is the norm, right?
Oh, yeah.
You want it.
Or even think about it even at a crazier level, like what if you're building operating systems? Like I've thought about this. Like, could you imagine like just the weight of like building like a main feature for instance, like the folder view in Mac OS, or like the system like the networking protocols in like Windows, like I could just imagine like the amount of effort it takes to not only like work on that, but to like build it in like an environment that actually like allows you to test it end to end. Like that to me, like once you start to get into systems at scale, like my brain doesn't work anymore. Like, okay, so you have to separate everything out, almost to the effect that it's like, you just hope that everything works when you put it all back together, because you never get an opportunity to test something like that end to end ever.
Exactly. It's kind of like we have to use VMs, right? It's our simulation environment, basically, for us engineers. Yeah. And
but what if you're building the VM software? Like, what if your product is the VM software? How do you test the Yeah. Anyway.
You can, turtles upon turtles, like
Yeah.
it's, yeah, the closer you get to the bare metal, the harder it is. And
Yeah.
the more you rely on, I guess, some manual testing, manual QA,
Yeah.
there's just no way around it at some point.
Yeah. So this kind of brings me to like this like area of focus question, right? Like you mentioned kind of like mobile, like bare metal, like you can have all these different abstractions of what kind of technology you like working with, right? So, to go back into your kind of tech progression, your career progression, right? Your linear story. Like when did you start to figure out like things that interested you? Like I know for me, like the goal was always like, oh, I want to like build video games. And then I found out that building video games is not a good idea. Like for a lot of people, right? It's a very hard job. Like what sort of technologies
Exactly.
like triggered your interest? Like obviously kind of knowing who you are, I figured out like eventually what technology interested you. But like initially when you first started working in industry, like what are some of the technologies at the time? Obviously that's going to date yourself, but like things that you found fascinating.
Well, I started off with non-web related stuff, non-cloud related stuff. So my very, very first job was actually in Romania. I was working on this CAD software for building buildings, actually like real life concrete buildings.
So very engineer focused, right? Engineering was your customer. That's interesting.
Yeah. It was by accident. Like I wasn't very thoughtful about my sort of career direction, and there aren't so many options back in Romania, to be honest. Like
Sure.
there's a bunch of cool stuff. Like I applied to Ubisoft, and
Yeah.
there's
Yeah.
some
Yeah.
interesting places I might have gone to, but this one it involved like 3D stuff, which like I was mentioning, I was playing around in high school with,
Hmm.
and it involved building something real. And initially, that was just amazing, just to contribute to something that's going to be real. That the
Yeah.
best feeling is in the world as a junior engineer, right?
Yeah. Yeah.
Later on, it became more sort of. I went to university in London at some point at Imperial College London, and I was just looking for a part-time job just to pay the rent, really.
Yeah. Yeah.
And my sort of tutor in university, she just knew a company that was hiring part-time, and they were also teaching people how to be good engineers and so on. And that ended up being this company called Shift, which was the creator of RabbitMQ.
Yeah. Yeah.
So that was my first interaction with RabbitMQ, and it just took me in that direction with messaging, and that's my first real interaction with just cloud related stuff,
Yeah.
right? And I remember, very vividly, colleagues were saying, "Oh, C++, great, welcome to the real world." Like, we're
Yeah.
sort of saying like C++ is not really used in cloud, it's
Yeah.
not something common. And they told me you have to learn Python and a bunch of these other
Sure.
newer
Sure.
sort of languages where you can build fast and be very productive and so on. That time I learned Erlang as well, which is super interesting as a programming language. But really, once I got into cloud stuff, the distributed system aspect was really interesting to me, and I knew
Yeah.
I kind of want to be in that space for quite a while.
Yeah.
Yeah.
Yeah. I mean, like the whole idea, I mean, and we talked about this a bit briefly. We talked about it before we got started. Now we've talked a little bit here, like the idea of abstraction, right? Like obviously like networking protocols are challenging, right? Like, you think about like, I don't know if you've ever been asked this question, like during an interview, like how does the internet work question,
Oh yeah.
right?
Oh yeah.
Right. And
Exactly.
like, even if you know the answer, like it's very hard to like eloquently say it without kind of sounding like an idiot. Like at least that's my opinion. That's why I've gotten it a few times and I always kind of laugh and I say, okay, well, this is my attempt. I say before I start, this is my attempt to tell you how the internet works.
Yeah, there are
But
many
like,
variants of that, right? Because
yeah,
like
exactly.
everyone dives into different parts of it, and it can be very complex if you really talk about it end to end. You can probably talk for 12 hours about it.
Oh, sure. Yeah, there's like white papers have been created, and anyway, but like the idea
Yeah.
of like message brokers in general, right? Like trying to abstract some of the real challenging primitives of just talking to other devices, period, right? Like, was that and here's a question for you around your curiosity around tech. Is it because, were you interested in working in that? And you could say if it was because it was a job, and I respect that. But was it because like some of the problems you were solving were trying to make the average developer's experience a bit better? And maybe you didn't know that at the time, but eventually, did you feel that way?
Yeah, at the time, it was more like a job.
Yeah,
really.
sure,
Like
sure.
I was just trying to pay the rent, really. But over time, I started thinking about, what are the primitives of the internet or of
Yeah.
distributed systems and so on. And I think many people have gone through this journey, thinking about, the ways different systems can talk to each other. And I feel like as an industry later on, we sort of agreed that REST is a really good thing,
Yeah.
and this should be sort of the standard. And
Yeah.
because everyone knows how to talk, between a server and the web browser, and why don't we reuse that across servers and so on? It wasn't quite as obvious back then, and of course the use cases can vary. Like if you have queuing involved, you cannot use REST, right? So that's where maybe messaging comes in. So I think AMQP is this attempt to become a standard as strong as HTTP in a way.
Yeah. Sure.
And I feel like it hasn't been quite as successful as HTTP.
Sure.
It's more like an attempt, but there are many variations of, there's maybe the streaming use case, which maybe is not covered so well by MQP. You have, Kafka and Kinesis and so on, which I feel like they're kind of different. And then there's many other sort of queuing platforms that are unrelated to MQP. They just invented their own sort of protocol.
Sure.
And I think that's fine. I think creating the right abstraction sometimes, in some cases you need very strict sort of standards-based direction. In other cases, I think if it's simple enough, you might be better off using some maybe imperfect abstraction and fitting it to your needs. And that's fine too. Sometimes simpler is better. You don't want to sort of create a very complex abstraction. So yeah, I don't know. Like, it's hard to come up with a rule. Like I was always asked by my team, like, how do we come up with the best way to think about what features to add to the product and what features not to add? And it's always really challenging to walk that fine line, creating this sort of API that is, if you add too many things to it, it becomes very difficult to learn and to use and to read, maybe as a programming language in some cases. And if if maybe you're not adding enough features, it can become too simple and not serving all the use cases. And I always think about the distinction between Docker, Swarm, and Kubernetes. Like Kubernetes won because it was complex and it solved everything we needed it to solve, right?
We don't have time for that conversation right now. We really don't.
Exactly.
I do. So you mentioned a couple of things that I find very interesting. Like, firstly, like the idea of like, REST being at a point in time, like SOAP related messaging or SOAP related transfer of like became like very quickly obsolete. Like we don't do REST or we don't do SOAP now. Like REST is the way to go. And I'd love to get your thoughts, because now we're getting to this world where like REST is still king, but there's like gRPC, which is very much just like, hey, like we're way faster. Maybe you should use us. Like, do you see, and this is, maybe conjecture, like, do you see a particular point in time where gRPC unseats REST is like the de facto standard for how we communicate with each other?
I think it depends, right?
Yeah.
There's the trade-off between, sometimes the wrong abstraction is a little bit better just because it's simpler. And there's going to be always cases where maybe protocol buffers and gRPC are just too big of a hammer, right? For a certain situation, right? You don't want to bring all that abstraction with you and, create a very complex sort of setup just if you have a very simple sort of, REST API. And I think REST, protocol buffers especially, they brought us more than just a protocol to talk to each other, like in a server-to-server environment. They also brought us some consistency around how we define the schema.
Yes.
And I think that's something, and also the idea of forwards and backwards compatibility, and those things that work really well in a distributed system setup where you're upgrading some servers in a different schedule on a different release cycle than other servers, and then you have to make them cross-compatible. And it sort of introduces this idea that everything has to be always cross-compatible no matter
Yes.
what.
Yeah.
Otherwise, you're going to break stuff. And I feel like more than just speed, raw speed on the network that protocol buffers bring, I think just the engineering side of it, the way we collaborate as humans around defining the protocol and pushing it to production and making it, releasing it and so on. I feel like that's the bigger contribution of protocol buffers.
Yeah, I mean, I think about it as a developer who's kind of lived those three lives, right? Like, I got started building like SOAP-based systems, right? Like, give me a WSDL file, like, so I can actually build a client for it, right? Great experience as a developer, right? Good, bad, or indifferent, like the ability, like, oh, just give me a client and it works, awesome. And I understand that like REST eventually became more flexible, so like it takes a thing. And then I see like protocol buffers and gRPC. I'm like, oh, so you're building me clients again. Like,
yeah, exactly.
It's just,
exactly.
It's so, like
kind
the
of like
world,
a step forward and a step backward.
well,
right?
no, I don't think of it like that. I think of everything's a circle, right? Like we talk about this all the time with distributed systems in general. Like distributed systems have been around forever. Like as long as computing has been around. And then we got to this point, this kind of inflection point where it's like, okay, like we don't need distributed systems. What we really need is like everything on the same box, because that reduces latency and all these things. And then eventually now we're at this point where it's like, well, we need, like, it's too heavy. The entire box is too heavy, right? So, and you're talking about like the complexity thing, right? Like you can't throw Kubernetes at everything. You can't throw gRPC at everything. So I'm very much of the belief, I think like you are as well. What you're saying is like, what problem are you trying to solve? And here's a technology that best solves your problem with the minimal effort. Because I think that's the really thing that developers care about is the minimal effort, right? If it takes you 10 years to learn architecture to build something, like that's obviously an exaggeration, but then we run into a situation where it's like you're spending more time like trying to get the thing to work than innovating with the thing.
Right, exactly. And we were talking about this before stream, but like this background of coming from big tech versus small tech, right? That plays into these kinds of decisions. Like in big tech, you're always going to be incentivized to build for scale and for long-term maintainability. And so you're going to be using the most, probably on the complex side of most tools. You want to be pretty sort of, you have to have a minimal set of features in there, and then you're going to use the biggest hammer you have, right? Whereas in small tech, you maybe are using, you're making real trade-offs. Like there are very limited resources in the team, and you have to build this thing tomorrow, right? Like or yesterday or something, and now you're gonna make a decision between going to market first, fast, and picking up some valuable feedback that can improve your product, versus taking a couple of years to build a whole thing, and then maybe you build the wrong thing, and then you have to start all over again. Maybe go bankrupt, nobody's gonna fund you or whatever. So I think the incentives are very different in these two environments, and I think as an engineer, you're going to learn from each of these environments very different things that are very sort of, they're just going to build you up differently. And if you can combine those two benefits together in a single career, I think that's very, very useful to, shaping you as a good engineer.
Yeah, I love the idea of like the size of the company, the scale matters, right? I love this conversation because you are completely right. Like the larger the company, the tendency to have a requirement is like, but does it scale, right? And you see, and you see this plenty of time where like technology decisions are made incorrectly, and then large companies have to kind of pivot and kind of think about how they adjust and rewrite software or whatever. And you made a very interesting point. Like you might not get that luxury at a smaller company, right? Because you might only get one time to get to market. And if that get to market doesn't go the way you want to, like I've imagined many, your backers, your venture capitalists, they're like, well, where's my return? Oh, like we need to kind of reiterate and like build some, like, no, we're out. And then you're done, right?
Exactly.
So I think it is very interesting. And I mean, And this doesn't mean that small companies traditionally like build software that doesn't scale. I think what it means is that you have to be far more prescriptive in what you're trying to do. Otherwise, you run the risk of making a mistake. So I think it's funny to say there's a lot more like conservative thought to ways to mitigate risk with small companies, but it's very true. You don't think of a startup as like a company that cares about risk. Like, okay, well, we're just going to move fast and fail and all the silly cliches. But at the end of the day, like, you need to be somewhat conservative because the money that you have is like all the money you have until you start turning a revenue, right? So it is interesting to think that it's like, oh, maybe the bigger companies have more flexibility to inherit risk because of their size, and small companies don't have that luxury.
Yeah, in a way, you're kind of forced to create this culture of experimentation where the goal you're going after as an engineer is not building the perfect software. You're building the next iteration that gives you more information from your users. Yeah. And that's a very different sort of approach in the way you code things, the way I think best practices and clean code and so on, I don't think you throw those away in a startup necessarily, but you're still you're just being scrappy in some ways in which maybe at a bigger company you're not forced to do. And that allows you to move faster with your experimentation, learn things more quickly. And that allows you also to sometimes innovate faster. So that's how small companies can take on big ones, right? The big ones have an incentive to just build something perfect with no sort of user interaction or not as much. And then it might not be the perfect thing, that you're building. It might, fall to some other, fallacies of like, being not a good product or a product that nobody uses.
Yeah, and this kind of stemmed, for folks that are listening or watching, like we had this conversation a bit earlier because we were talking about, so your background specifically, like you've worked in large companies, like you've worked at VMware, you've worked at Google, and you've also kind of worked at smaller companies and built things yourself. And I asked Vlad, like, what do you prefer? Like, and be honest. And he kind of gave me like, let's have this conversation on stream. So I would love to kind of get your thoughts. Like, obviously there are goods and bads of all these approaches, right? But like, what are some of the takeaways that you have from large tech that you really enjoyed? Like, I don't care as much about things you didn't enjoy because that's beside the point. Like, what are some of the things you really enjoy about working at big tech, and how have you been able to attribute some of those things you liked into some of the things you started on your own?
Exactly. I think in big tech, you're going to learn about, how to do things properly, how to do high scale engineering, how to, test things really well, how to, serve customers with a high sort of bar of product quality and product reliability. And you're going to learn to work with people in big teams and work with big code bases and, figure things out from an existing really large code base, trying to make a small contribution, but very key contribution that's going to change some things. And, the dominoes could fall in the wrong way and so on. So you're going to learn about a lot of those sort of difficult, large scale development things. And then you're going to go to a small company, right? And you're going to say, back when I was at Google, we did things this way and that way, I'm guilty of that. I've done that many times myself. But after that, you're going to learn about how to make trade-offs, right? And how to make something from nothing in the most efficient way possible while learning from users, keeping a tight feedback loop with your users, making sure you're building the right thing. And you're going to learn responsibility because that's going to, in a small team, everyone wears multiple hats. Like you're an engineer, but maybe you're also buying donuts for the team or whatever, like it's going to be such a mix. You're going to talk to customers a lot as an engineer, which is almost unheard of at the big companies.
Oh, sure.
And, having that sort of mission alignment as an engineer at a small company, I think is something that is kind of unique. You're building something and you know exactly how it's going to influence the company, how the company is going to be successful because of the nuts and bolts that you're building right now. And they're like this interaction with the market is much, much closer at a small company. And like you asked me what I prefer, I would say for me, I'm not good at the big company stuff, mainly
Sure.
because I'm just not good at climbing the career ladder. So that
Interesting.
I can only talk about me personally.
Yeah.
Others are really good at it. They can become amazing people and thrive in those environments. Um, but for me, like I mentioned, my motivation is driven by what is the most what is the most impact I can have upon the industry, upon the world, and so on. And for me, my journey seeking for that biggest impact has led me to this kind of career where
Yeah.
I'm working, starting a small company, but maybe building a big one over time.
Yeah.
But it's been the way I've been more successful rather than trying to climb the career ladder.
Yeah, and I mean, and I think one of the things, it probably goes back to like your idea of, you're curious by nature, and, and not to knock working at a big tech company, like there are situations where you can't be like as curious, sadly enough, because you're focused on, I have to ship said feature for my product and all that sort of thing, right? I mean, and
Right.
I'd love to kind of, as we, talk about sort of your journey, like you worked at tech and then you kind of made work in big tech, and then you kind of made this pivot, as you mentioned, to kind of wanting to do your own thing. And like, some of the things you've worked on, like ShiftLeft, and, now you're, working with Earthly Technologies, like as somebody who, you know, has gone through like the pain of, working for the big tech company, trying to figure out, like you mentioned, climbing the ladder, and then kind of being more free with the idea of like owning your own path. Like, was it terrifying? Was it freeing? Was it like, how was your initial thought when you're like, okay, I think I have something here that I can actually turn into a business?
Yeah, yeah, yeah. In startups, they say you're gonna get two feelings, either like high highs or low lows, and it's always this roller coaster going up and down.
Yeah,
And the truth is that the highs aren't quite as high as you think, and the lows aren't
sure,
quite as
sure.
low.
That's fair.
But every company goes through those, and I think initially it wasn't so terrifying, mainly because I was not doing a good job at it. So I
That's
had before Earthly and ShiftLeft, I had many attempts that did not work out, and
sure.
I was initially just an engineer in my bedroom trying to
Yeah,
code something out,
yeah, yeah.
thinking I could change the world with just code alone. And sometimes you can, but it's much harder. You have to go out there and sort of figure out what is actually needed. And I didn't do it quite so much of it. And so my initial attempt was kind of, I would say, lonely, not necessarily scary, more so than anything. And then it's maybe scary from the financial standpoint because you're gonna run out of money, you're gonna get a job, and then go back, try and get again, and so on. And so I think the financial roller coaster is maybe something you have to deal with.
Yeah,
At least I had to deal with it. Sort of
sure.
starting something, having like I don't know 6 months of runway, trying to figure something out, and then running out of money, going back to get a job, and so on.
Hmm.
Yeah, I would say it became a bit scarier when it started to be successful. That's when you
Yeah,
build a team and people rely on you, and there's a lot of pressure, and maybe investors want some kind of outcome, and then you have to make sure you're using the money the best way possible, and there's a lot of responsibility involved with that. And I sort of liked it, like it was definitely stressful in the beginning, but I also like the fact that, going back to that motivation, impact, and so on. Of course, if you're going to have impact, you're going to have a lot of responsibility.
sure,
So it
sure.
comes
Yeah.
with the territory. So it's something I sort of learned to deal with, I guess.
Yeah, this is pretty interesting. Like, I mean, and thinking of, what problems you can potentially solve with whatever your idea is, right? And like thinking of Shift Left, for instance, right? Like, AppSec security at, at the point in time, 5 to 6 years ago, like very, 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 very important stuff, right? And
Right.
like, and now thinking about what you're doing at Earthly, which is like, okay, now we're going to talk about like developer tooling for containers, right? Like,
Hmm.
I mean, I don't want to say that you're pretty on the nose with like problems the tech industry has and like trying to like find solutions for them. But what do you equate that to? Because it's fairly true, right? Like, I mean, you were working on messaging stuff like when messaging became very, very important. And then you started working AppSec stuff when that became very important. Like, do you just kind of have like a nose for like the trends of tech and like not to over conflate like what, some skills that you have, and you don't need to share them if you have them. But like, so what is it about, some of the things that you find interesting and how you've been able to kind of map some ideas to them?
I think there are two elements to this. One is just being up to date with what's going on, listening to podcasts like this one, or like reading, following interesting people on Twitter that talk about, what's new in the industry, following hacker news and so on. I've always sort of kept in the loop with that, mainly because I just liked, being on the edge of technology, really. Yeah. To be honest, the technologies I ended up working on, somewhere maybe by luck, like I was mentioning in the beginning, I just worked on RabbitMQ because I was just paying rent, Later on, it became much more about solving some problems that I had myself as an engineer.
Yes.
And I guess the combination of being aware of the technology space in general, software engineering in general, made me sort of aware of what engineers typically have as problems. In fact, you could say developer tooling for containers is something that people deal with today, but actually it's been coming for like a decade, So, in many ways, I think some of the traditional ways of doing these things were sort of out of date, so much so that I was for sure that somebody's going to come and build this thing and it's going to create this amazing product. And then a decade went by and nobody did. And I figured, I got to build this myself, So in a way, it doesn't feel like we're so cutting edge as much as we're late to the game, but the industry really, really badly needs this. I feel like.
Yeah, that's a good point. I mean, I'm as somebody who has been working with containerized architectures for 5 years or so, I definitely can relate to the fact that like this is like 10 years of the making of like, okay, can we please like have something? But obviously, and this is just to call it out, like the problem must have been too challenging to address, right? Because otherwise, like a big tech company or a startup would have created some product that would have taken over the world. I guess you could say Docker to an extent did that, right? But like, I mean, good, bad, or indifferent, like Docker has its problems. And, if you want to like extend Docker, like Kubernetes has its problems. But like, especially from the developer standpoint, right? Like, I mean, talk to any developer how much they like Kubernetes and you'll have a great conversation with them, right? I think, and the beauty of containers, obviously, is that you can do very efficient stuff without having to worry about it working anywhere. But like from a developer tooling perspective, you're very dependent on like having a fairly beefy machine. Right. And like, I love to, I love to get your, like, especially if you're going to have Docker desktop running all the time. Right. So I'd love to get your thoughts on like, this is specifically around the accessibility of technology, right? Like not everybody can afford a laptop with 16 gigabytes of memory or whatever, right? Or they're working on on a device that's, doesn't maybe support like the latest chip architectures to make things super secure, right? Like, how do we do better in this regard of not introducing technologies that only a very limited subset of us as technologists have access to?
Yeah, I think, in many cases, you can get started with simpler setups. Like, of course, if you're not getting the M1 or M2 laptops these days, you can still use your sort of older sort of computer. In fact, I feel like in the last maybe 10, 15 years, like the performance hasn't risen that much if we ignore the Apple Silicon trend, right?
Sure.
The performance hasn't
Moore's
risen
law has slowed
so
down,
much.
right? Like Moore's law has definitely slowed down to an extent. And now instead of them following Moore's law, like chip makers and hardware makers, they're just like adding more chips. Like they're not they're not extending the power of the chips. They're just adding more chips because now we have the ability to make smaller chips, right? So they're getting around Moore's law in a different way.
Exactly. It's still evolving. Like, these things are, like less focus on latency, more focus on bandwidth, I guess, with
Yeah.
more parallel chips and all that.
Yeah.
Overall, I think if you're junior and you don't have like the access to like a high-end machine, I think you can still do containers quite well. I mean, it so happens on Macs, you need virtualization to get access to containers, and that's what Docker Desktop does. And sometimes that's why you need a beefy machine. But if you just run Linux on your old laptop, it'll probably handle quite a bit of quite a few containers, especially because of the fact that when you run something locally, you're not really serving production traffic, so you don't need all that memory. Your services aren't so caught up in just don't use quite as many resources. Maybe the only thing that kind of uses a lot of resources is maybe the way we do caching in Docker, which uses a lot of hard disk space, and sometimes maybe that is slow on older machines. So in some ways it can be better. In some ways it can be, I guess, worse. But I think overall, more and more technologies will also be sort of cloud friendly in that you can use the cloud as the way to do development. Like you don't have to have like a high-end machine. You can just rent out a few hours on some machine in the cloud, or use some service that does that for you underneath. And of course, with things like Lambda and serverless and so on, you can, it has trade-offs, like there are good and bad things that come with that, but you can also just do testing in the cloud alone. And in some simple setups that works fine.
Oh yeah, I totally agree that if you can use a cloud in some capacity to abstract like your developer environment, you definitely should. Like things like GitHub code spaces exist for that exact reason. And like awesome, like the idea to me is pretty amazing. And I love the idea. Like I remember I was taking a look at the Earthly Technologies website a few days ago, and like you mentioned like Dockerfile and Makefile having a baby, right? So like so and it's very catchy, and I applaud you for that. So what is it specifically about Earthly Technologies, and what is the problem you're trying to solve, and how are you solving it in the way that you think makes sense for a lot of developers?
Yeah. So I waited for this kind of thing to come to market for a long time. Like I was mentioning, I wanted this myself. And so I saw the space of CI and the space of build systems being kind of distinct and separate. So you would consume the CI in the browser, right? And you would wait for Jenkins to kick in or whatever, and then wait for the logs to show up. And then after 23 minutes of waiting, you get to some point where it fails. And then you start all over again to test the thing yet again with a small tweak you did to the code. And that felt sort of unusual to the way we did the rest of software development. On our computers, we use the build systems, and they're fast, and we can do this local iteration like with great sort of efficiency, right? Like it takes maybe seconds in some cases, depending on the language and the setup and so on.
Sure.
And we wanted to create this bridge between what is something that you do sort of locally, but also can be taken as the CI/CD script itself. And that means you could run your CI locally, which is something nobody has done before, and get that fast feedback loop. It has caching and things like that, and be able to be much more productive when you debug CI/CD pipelines, when you create new CI/CD pipelines from scratch, and so on. So these various sort of things that I needed for myself, we just put in the product, and essentially we merged the build system with the idea of a CI/CD platform. And that's basically what the summary of Earthly is. The fact that we had make files and Docker files in there just is a way for us to be very easy to use and understand, really.
Yeah, sure.
And that's where it comes from.
I think if you're introducing any new concept, it's very valuable to kind of show similarities or even gaps in existing things, right? And I totally agree. Like the amount of times that I've had some YAML that I've had to like update and then test and then wait 5 minutes for it to fail and then test, like that loop is painful, right? And like the idea of like something sitting in the middle to like allow me to eject myself out and inject myself back in if I have the ability to make some changes there without it literally taking this very, very long loop is very valuable. So, I mean, I think
Exactly.
it's like you mentioned this, like the 10 years thing, right? Like, obviously, it's not safe to say like you're not the only CI/CD tool, right? And there are tons of other CI/CD tools out there. And the fact that none of them have like tried to address this exact problem is very interesting. And I've always kind of been curious as somebody who is, you know, I've had my hands in Jenkins, I've had my hands in Travis CI and Circle CI and GitHub and Visual Studio, Team Foundation Server and all those sort of things. And it's like the loop, like the second the code gets off of your machine, the loop just gets bigger and bigger and bigger. Right. And I guess that makes sense because obviously scale and all these things. But it is quite interesting that it's taken like, I mean, DevOps has been around way longer than containers have been, right?
Exactly.
So, yeah. So like the idea of Earthly, like when you originally were like I guess you said you waited and waited and waited. I don't want to create something and then literally some big company comes over the top and create something, right?
Right. Exactly.
But eventually I imagine you got a bit impatient and you're like, okay, like if it's been this long, I might as well take the risk now, right?
Exactly. Yeah. I mean, you start off with something very simple where you say, you know, does this idea even make sense? Or is it just something I'm dreaming about and maybe nobody else is thinking about? So like in true startup fashion, what we did was just create a simple MVP, very basic implementation of it and put it up on the internet. And it kicked off. It took off on Hacker News and on Reddit, and that was the initial validation. Okay, so it's not just me, you know, like there's definitely something here. And I think in the process, there's always been this thought that maybe somebody else is going to build it, but really, it's, you know, so much time has gone by, we don't really think about that anymore. Like it's if they hadn't built it in so long, that they're never going to build it, right? Unless maybe we inspired them and all that. But I think people really needed this because the fact that, you know, CI/CD has such long feedback loops, and even when you push it to the cloud, even then you repeat so much computation, like you reinstall all your dependencies and you sort of redo a bunch of steps that are very common, and that takes at least half of the build time. Yeah. And we're, as an industry, we've gotten used to that being the norm, and I think that's kind of bad, you know, like that shouldn't be the norm. And like nowadays people say, oh, like I've tried all these different CI/CD platforms, they're all the same, they just have different syntax, and then they just give you the same thing. Well, nobody has really thought about internally about the performance of that and how to really address that fact that things are repeating every single time exactly the same way. In a way where we went from Jenkins, where the build environment was shared between the different runners. So there was less security, I guess, less reproducibility. We went to this cloud-based thing where each build has its own sandbox. And that's amazing for like security purposes and so on. But in doing so, we've taken away some key performance and some key caching from that sort of migration. And I feel like that is something painful. And what we do at Earthly actually is we allow you to use these sandboxes, which are containers actually. We all know and love, but also you use some caching that does not repeat what you've done before. So you can, you know, the way Docker file layer caching works, we took that and put that in CI/CD. So like not just building, not just for building images, but now for building unit tests or regular artifacts or integration tests and so on. So like the whole layer caching works in your favor. It's still isolated, so that's the key advantage there, where you're still benefiting from those security best practices and the reproducibility that comes with it, but it's not affecting your performance because you can still use the caching.
Yeah, I mean that's like from a developer standpoint, I immediately go, oh, like you're simplifying the friction, like you're reducing the friction, right? Like I think I'm excited to see where this goes because I think, you know, I think that the positive is that if this is a forcing function to the industry to quote unquote fix the problem, that's awesome. and you're already here. So you know what they say about people that are there first. I highly, I want to say, like, if you're a developer and you're curious about learning more about earthly.dev, be sure to put a link to that in the show notes for this particular podcast episode. I think that as developers, any tool that we can adopt to make our lives a bit simpler, and I can tell you, like, personally, like, the iterations on trying to, like, get builds and deployments to work, like, something that can make my life a bit easier, I will throw all of my money at. So, awesome. I mean, thanks for Vlad for coming up with this idea that literally has been like 10 years of waiting in the making, right?
Nice. Yeah. Thank you for saying that.
So we're about to wrap up the show, and I love to, at the end of it, I love to ask my guests this little surprise question. And based on the conversation we've been talking for about an hour, and if you can kind of think about the conversation we've had, just general in tech, about open source, about all the things that you've kind of touched in your career, but you only had one word to kind of summarize that feeling that you had, what word would that be?
For me, I think it's privilege, because like, I've had this career progression, which was sort of a twist of lucky turns, I guess, a series of lucky turns. And I was almost going to go into physics and so on, and maybe I would have enjoyed physics a lot, but I really enjoy what I do now, and I feel like we have this opportunity to make a difference for people, and not many get this sort of opportunity, and I really like that feeling.
Yeah, I totally agree, and I think the word privilege works on so many levels for a lot of reasons, so I appreciate it. And that's the end of our show. Like, again, Vlad, I want to thank you so much for coming on and chatting with me. This has been a pleasure. I've loved learning more about your career and the things that you've been working on at earthly.dev, and I'm excited to see more. So, for the folks that are listening to this, like, do you have any parting words, things you'd like to add at the end?
No, not really. Thank you for having me on the show, Isaac. It has been an honor.
Yeah, thank you so much, Vlad, and thank you for everybody for tuning in, and hope you enjoy the rest of your day. Take care.